Hey, it's James from Hamilton Effects here. Hope you're having a good day. Today's video is going to be slightly different. It kind of follows on from, I guess, last week's video where we were looking at the twin boost, talking about how it's two single transistor circuits. And then when both of them are on, you kind of get this dual transistor dynamic kind of drive that can turn into fuzz. And I think I mentioned how like the Fuzz Face circuit is two transistors, one going into the other one. And so I guess today's video is a bit of an experiment. We're going to see what each of those kind of transistors in the Fuzz Face circuit, what each of them is doing. So we're going to take a tap out of Q1 and a tap out of Q2. And then if they sound interesting, if they sound usable, then maybe we'll make it into a full pedal that when both sides are on, you get kind of like a Fuzz Face circuit. And then you get two interesting other flavors when either transistor is bypassed. So yeah, there's some interesting challenges, but yeah, we'll get stuck into it in just a sec. You're going to have the barking dog and messy view of my workbench. So it's going to be a bit small, I'm afraid. I will at points do some cropping, but I have here, what's the name of this brand? Is it Copper Sound? Make this kind of breadboard with built-in power supply, like a bypass switch, and jacks in and out. I've got my cup of tea. I've got mess surrounding everything. And yeah, so these, oh yeah, so that's plugged into my pedal board down there. Got my laptop there with the schematic up from Electro Smash, super helpful. And yes, right, a few things that we need to get started. I have some breadboards over here that I'm just gonna be pinching stuff off of, like little jumpers and that kind of thing, jumper cables. So to begin with, let's join the powers and grounds. Just interrupting my own video to say, if you're enjoying this, then please do subscribe, please do press the like button, and yeah, in the comments, let me know what you think. And this is a bit of a spoiler, but I guess you will have seen from the thumbnail. If you like the sound of this pedal, this creation that I get to make over the course of this video, this kind of fuzz that you can split in half and have either one transistor working on its own, you'll hear the different sounds coming up. Yeah, you'll hear all the different thoughts I have about it as well. But yeah, this one-of-a-kind pedal from this video is for sale. If you want it, drop me a message. Okay, back to the experiment. Alright, let's plug in so that we can record audio. I don't know if this is too, what's the word, optimistic? Let's tune up quickly. Right. No sound as of yet, so let's troubleshoot them. There we go, that was the problem. I had it wired up backwards in effect. I had put it so that the gain was turned all the way down rather than all the way up. So there you go. Let's change this. And we have a fuzz face. There we go. It's noisy. It's always going to be noisy on a breadboard. Okay, let's put the volume control back in. There we go. Okay. That's our little breadboarded fuzz. This is my Embers fuzz. So that is good fun. We've breadboarded a reasonable sounding fuzz face. Next stage is to change where we're taking the audio from. So at the moment, obviously it's going through the whole circuit, interacting with both transistors, one into the other. But what I'm interested to do, and what we are very nearly about to try, once I've pulled out another jumper, is to take the signal that goes into Q2 from Q1. Let's leave as much of the circuit intact as possible, because everything is going to change if you change one thing. The fuzz face circuit is so, like, finicky, is that the word? So there we go. So this is our clean signal. I have no idea if this is going to work. Okay, do you hear that? Very interesting. Let's plug in Q2 to Q1 again. Here we go. That's positive. Interesting. Yeah, so that is woolly, that is... This is the kind of the bridge pickup of my telly. This is the kind of dry sound. And then we engage it. It's like on the B and E strings, there's no fuzz at all. Interesting. So that's what Q1 sounds like. Super interesting. Right, let's disconnect that then. So we're going to change that cap so it doesn't go into Q1, just comes over to a blank space. So I'm leaving Q1 connected to Q2, but there's no kind of input going into it. Again, there's the dry. Oh, nothing at the moment. Interesting. So the gain turned all the way down, we're getting signal. Okay, this is interesting. So we have a solution that's shouldn't work. There you go, you can hear it dying. Because it's not biased properly. What we need to do is add a feedback resistor between the base and the collector, not the base and the emitter. I've just tried a couple, but wasn't getting any results I was happy with yet. I'm just checking out some different values. Let's try 470k, but I still feel like it's not going to be high enough. It's an interesting sound, I just want it louder, you know. That's volume all the way up. I guess one way that I could make it louder is what I've done with the embers and add a third gain stage on the end as like a clean boost. Not super keen on that. So what we ended up with there was our standard fuzz face circuit. The only thing that needed to be different was I added in a feedback resistor between the base and the collector of Q2. I also changed the Q2 output capacitor to be 100N rather than 10N, just to kind of let more low end through. But yeah, now we need to do some designing, work out what it's going to look like on an actual board. And I think probably what I'll do is I'll add the same output boost that I do on the embers, just to give us plenty of volume on there. So I've planned out what I'm going to do. Yeah, got the design. I'm not going to use the kind of boost that I use at the end of the signal chain on the underdrive. On the embers. I'm not going to use the boost that I use at the end of the signal chain on the embers fuzz, because we're not underdriving anything. And yeah, just nice to keep it simple and as is. It would make switching a real headache as well, like adding in the extra layer. So yeah, I'm going to get going, get building this strip board. I'm using the components. I'm probably just going to take them straight off the breadboard and put them onto the strip board. I've planned the little layout, and yeah, we'll see where we go. I think I've got a cool enclosure to use for this as well. So we're back for day 2 of this kind of fuzz pedal experiment. Finished off the board. I'm just going to load up my plan so that hopefully I don't get anything too wrong. The drilled enclosure ready to go. Right, let's see how far we can get this morning. Okay, we're in. Well, we're not in, but we're done. We're dangling. Moment of truth. We have power. Let's get stuff plugged in so that we can test it. So, swapped the soldering iron for the HX Stomp. Who knows whether I'll need to plug the soldering iron back in. Brand new circuit, so difficult to be super confident of the design. Okay, we've got noise. The guitar isn't plugged in, so that's good. As in, we know that the true bypass is working. Always a good sign. Classic, wired the gain in the wrong way round. Something funny is going on. So a reasonable amount of time has passed, including doing some teaching and having some dinner, but I think we're finished. I think the issue was working out where the coupling capacitors should go in the circuit, because obviously in a fuzz face you go straight from Q1, the transistor that's first in the signal chain, into the second one with nothing in between. But then if you want either one to work on its own, you need to have coupling capacitors before and after that kind of section of the circuit. So yeah, a little bit of trial and error, working where to put the pull down resistors to, but I think we're there. I'm about to do my first kind of screwed in attempt at a test. So let's see if it works. Super biasy, super gated, spitty. This is just the Q1 of the circuit, the first transistor in the kind of signal chain. reducing the gain. Doesn't do anything at all to this transistor. So here we have with some rough knobs on my attempt at splitting the Fuzz Face circuit in half. So gain controller's wired backwards, don't know why, silly mistake, but with both on we get kind of close to what should be the Fuzz Face, right? Fun, good fun, very biting as I adjust this camera that started to droop. Yeah, very biting, very cutting, a good kind of feel to it. Yeah, it's different to a Fuzz Face, but it is fun. This is what happens when you roll the volume down. I'm going to go on to, I'm playing my telly, I'm going to go on to the neck pickup. You don't really get much cleanup. You kind of, it cleans up, but it's noisy. Yeah, so it doesn't really clean up nicely. Maybe if there was a transformer in there, it might do. Doubt it though, actually. Here's the gain range. And interestingly, the volume control, well, the only way that I could get it just to have two knobs and to control the volume of each kind of side of the circuit is by making it a dual pot. So the volume control controls the output of the first transistor and the output of the second transistor, which means when they're stacked, you're kind of controlling how much of the first one goes into the second one. I've been running it with volume all the way up, so it's basically invisible. But as we take it down, it rebiases the transistors as you go, because it's such a sensitive circuit, kind of any change between them will do. It does eventually start to change the output volume, but we also get kind of different characters. You can hear that, that's really quiet, but biases really weirdly, because you're not letting much signal in to kind of help bias the second transistor. Let's just bypass it. Yeah, so it's still really quiet. So that's kind of what you've got from the two on together. Yeah, one of the main reasons why it doesn't sound exactly like a Fuzz Face is all the extra circuitry that's required to get it to play nicely as a guitar pedal. I mean, we have a bit of pop when we turn stuff on and off, but at least we don't have kind of oscillating amplitude and stuff like we were having earlier. So let's break each side down. This is Q1 in the transistor, in the Fuzz Face circuit, so the first transistor in there. Really interesting to see what it does on its own, because it is super Velcro-y and biasy with this bias resistor and this kind of layout, this way of doing things. The gain control doesn't do anything because it's connected to Q2. And the volume control is bypassing the first, oh no, it is the first one, so it is just a volume control. Quite interested to try that with humbuckers actually, whether they will drive the circuit a little bit more. But see, finicky and weird. That is Q1. Then we go on to Q2. Which I really like. Let's change key again. Kind of has a nice sustain, a nice kind of fuzz face thing, but really clean. It's, yeah, like a really nice single transistor boost stage kind of sound. Is really clean and really quiet with the gain down. popping, bit of fading there. This Q2 was the main offender when trying to solve the issues that I was having with popping and fading. You can hear it kind of rebiasing and being all weird when you change that knob. You kind of need it at full volume. But that's okay, because I think that sounds really cool. Yeah, I love this kind of rhythm sound. There you go, little sound demos of each of the different bits of this fuzzy experiment. So I've just been editing this video together and realised I didn't really properly finish it, but yeah. It's been a fun experiment, the old can we split the fuzz face in half. I'm pretty pleased with the results, really. I mean, it was a bit of a journey with challenges, like I think I've said throughout the video. It's a fussy old circuit, and so trying to split it in half and have it so that each side will work independently but also still be a fuzz face when together. I really like that second, like what Q2 is doing. That kind of textured, kind of clean overdrivey boost. I'm kind of designing a few things that are going to come out in the new year, and I think I'm going to use that as inspiration for something. It's yeah, maybe a little bit quiet. It's like full gain as unity volume, which I guess is like a classic vintage fuzz face thing. But anyway, so if you want this pedal, this one-off kind of experiment pedal, with all of its fun sounds, and then yeah, drop me a message. We can definitely work something out. It's a one-of-a-kind. Yeah, I'm not going to put any labeling or anything on that. You'll just know that it's from me at Hamilton Effects. But yeah, thanks so much for watching. I'd really appreciate it if you subscribed to my YouTube channel. If you liked the video, that would be amazing. And yeah, check out the website hamiltoneffects.com for all my pedals. And drop me a message or an email or anything if you want this fuzz pedal. All right, thanks for watching.